Hey everybody, this is Mr. K. I am making this quick recording to help some of the standard level 12th graders with their homework. And this one is specifically dealing with tangents and normals here. So really quick, let me just make sure my Mathematica is up and running because I'm definitely going to be using that. There we go, new document. We'll have this up and running. I'm sorry, I should have probably had this set up beforehand. Okay, so everything seems to be working now. Okay, now I just pulled up, one sample of the homework here. Find the equations of the tangents to the curves at the given points. So, all right, let's do number one. So the first curve here is y is equal to 3x squared plus 7. Okay, and it says it's going to be at x is equal to 2, write the x term first. So they want the tangent line, which is mx plus b. That's the thing I need to actually figure out here. Okay, so first things first, what is the slope of this curve at x is equal to 2? Well, the slope, recall, is just the derivative of this curve, okay? And then you evaluate it at x is equal to 2. So let's take the derivative of 3x squared plus 7. So here, how about we let f of x equal, what was it again? 3x squared plus 7. Okay, so now if I type in f of x, I'm going to get 3x squared plus 7. Nice. Well, the derivative means you bring the 2 down, and then it's 3 times 2 times x. Mathematica is pretty nice because you can just put a little prime there, and it'll do it for you. So the derivative of 3x squared plus 7 is just 6x. And then all I need to do is just evaluate this at 2. So I plug in a 2 right here, and I should get 12. There you go. So that means that my slope is equal to 12. All right. But I'm not done. I need to actually find out what the equation is. You know what I mean? All right. So the original equation is 3x squared plus 7. Okay, so what I really need is I need to actually have the tangent line here. So we know we're going to have 12x, but we need to find out plus something here. How do we find out what that something is? Well, let's see here. You know what would be nice is if I actually plotted f of x from 0 to 4, I guess. Looks pretty good. So here it is. And what I need to do is actually now also get my derivative here evaluated at x is equal to 2. All right. So I need the tangent line right about here. It's going to look a lot like that right there. Okay. So how do I find that? Well, if I knew if I have one point on the line, then I could actually use point gradient form, and that will actually give me the equation of the line pretty easily. So recall that point gradient form is just the slope, which is equal to y minus some point, why don't we call it like, y1, divided by x minus some point x1. So for a point x1, y1. So all I need is just one point, y1 and x1. Why don't I actually use this point right here, x is equal to 2. Okay. So why don't we actually do that right now? So m will equal no, I shouldn't type it in like that, but m will actually equal y minus something. We don't know what it is, but why don't we use x, and instead of x1, I'll put 2. Okay? So in the denominator, I'm definitely going to have x minus 2. Okay. But what is y1 here? Well, I need to know what this y value is when I plug it in for the curve here, which is just this original curve, but I'm actually going to plug in 2 for that, and then I'll have my curve, which should be 2 squared, which is 4, 4 times 3, which is 12, 12 plus 7 is 19. Let's make sure we're right. Yep. So now we have our y value, which is 19. Coming back to this point gradient form right here, I'm just going to change this to a 19. Now all I need to do is just fancy algebra in order to get this into y equals mx plus b form. Well, remember, this is the denominator. I can actually cross multiply that to the other side, and I'll have m is x minus 2 is equal to y minus 19. All right, so I just cross multiplied the x minus 2 to the other side. And I might as well just distribute that now. I'll have mx, you know what? We know what m is. M is just 12. Why don't I just put that in here? So this is just going to be 12, 12, 12, and 12. All right, so this 12 will go to the 12x. 12 minus 2 gives me minus 24. And why don't I add the 19 to the other side here? You know, because I need the y on all by itself. So I'll add 19 to that, and then I'll have y. So my final thing is just going to be y is equal to mx, which is 12x. And then what's negative 24 plus 19? Well, it's minus 5. All right, so y is equal to 12x minus 5. Cool. Why don't we actually see that plotted right here? So why don't we show that, and let's plot 12x minus 5 from x 0 to 4. Oops, I need one more brace. Aha! And as you can see, I actually have my tangent line right at x is equal to 2. Why don't we do a little plot style here? We'll make that red. There you go. So my tangent line is red. My original curve is just plain old navy blue. And as you can see, yep, that's definitely the tangent line at x is equal to 2. All right, pretty cool. So my answer is just going to be 12x minus 5. Cool. So that's that. Why don't we do the next one? So here I need to take the derivative of this, and why don't we do this a little faster? So this is going to be 4x squared minus 5x. So coming down here, I'll have f of x is equal to 4x squared minus 5x. Yeah, minus 5x. And this is evaluated at x is equal to 3. So f of x is equal to this. So f prime of x, well, let's see. This becomes a minus 5. This 2 comes down and you'll have 8x. So 8x minus 5. Yep, 8x minus 5. And I need to evaluate this at x is equal to 3. So if I plug in a 3 right here, 8 times 3 is 24. 24 minus 5 is 19. There you go. So now I have my slope. M is equal to 19. Pretty cool. But I'm not done. I need to actually get the equation into, you know, I need y equals mx plus b, because the equation of the tangent line should be y equals mx plus b, right? Okay, well, let's see here. I am going to put this into point gradient form, so the slope is going to be on the left. I'll have y minus y1 divided by x minus x1 for some point x1, y1. Well, why don't we actually use this point at x is equal to 3? So why don't we say this is going to be 3 for my first x point. And what is the corresponding y value? Well, I need to actually plug 3 into this. So this should be minus 5 times 3, which is minus 15, plus 4 times 3 squared. 3 squared is 9. 9 times 4 is 36. So 36 minus 15 should give you 21. Or I could just do this. There you go. So my y value is now going to be equal to 21. Okay. Now let's cross multiply. So I'll have 19x minus 3 is equal to y minus 21. And if I distribute this 19 right here, I'm going to get 19x minus, what's 19 times 3, which is 57. And then I might as well add the 21 to it right now. So, oops, this should be a minus in front of that. Yeah, so minus 36. So my final answer is just going to be y is equal to 19x minus 36. All right, and we can actually plot that right now. So why don't we plot f of x from 0 to 5, I guess, looks pretty good. And then let's plot 19x minus 36 from x from 0 to 5. Yep, looks pretty good. Why don't we put a little plot style on that? Red. There you go. So now, as you can see, I have a tangent line evaluated at x is equal to 3. The answer should be 19x minus 36. Cool. So that's not bad. Now let's do the next one. So find the equations of the normals to the curves at the given points. Well, all right. So this is going to be similar to this one, only now instead of m being the derivative, m is going to be the negative reciprocal of the derivative, because that's what the normal means. So y is equal to x plus 1 squared. All right, so why don't we type this in? X plus 1 squared. All right, cool. Now, the derivative of this, I can just use the chain rule, remember? So the 2 comes down, and then I multiply it by the derivative of the inside, but the derivative of the inside is just 1. So the final answer should be 2x plus 2 when you distribute everything out. Or 2 times 1 plus x, same thing. Okay, and this is evaluated at x is equal to 1. So I just plug 1 into here, and I should get 2 times 1 plus 1, which is 2. So 2 times 2 is 4. And there you go. But the normal slope is going to be negative 1 over m. All right, so I actually need to take the negative reciprocal of this. The slope is going to be m is equal to negative 1 over 4. All right, it has to be that slope right there. All right, so now that I have that, all I need to do is use point gradient form again. So on the left-hand side, I'll have negative 1 over 4, and this is equal to y minus y1 divided by x minus x1 for some point x1, y1. So I need some point on that curve right there. Well, how about I use this one? X is equal to 1. I can plug 1 into that, and that'll give me my little curve right there. So why don't we change this to a 1? And this, well, all I need to do for that is just say, okay, f of 1. So if I plug in a 1 right here, I'll have 1 plus 1, which is 2, and then 2 squared, which is 4. And there you go. So this one should be a 4. Okay, let's do a little bit of algebra while we're here. So I cross multiply the x minus 1. And I'll have negative 1 over 4 times x minus 1 is equal to y minus 4. Write your answers in the form ax plus by plus c. Okay, I think that's fine. And now I can just distribute this negative 1/4. Why don't I actually change this to a negative 0.25? Because I think that my math loves decimals a lot more than fractions. So let's distribute that. So I'll have negative 0.25x plus 0.25. And why don't I go ahead and add the 4 to the other side? So plus 4 is equal to y. So my final answer is going to be y is equal to negative 0.25x plus 4.25. If you would like to see what this looks like, well, I'll just plot f of x from 0 to 2, I guess. And let's plot this thingy from 0 to 2, but I'm going to give you a plot style of red for my tangent line. And this doesn't look right because the aspect ratio is way off. So why don't I actually change the aspect ratio to 1? Still looks kind of weird, doesn't it? Uh, no. What's going on here? Oh, it's still it's still not this thing is still not graphing the right way. Okay. All right, let's get the plot range. Let's change it to 0 to 6 and 0 to 6. That ought to fix it. Yeah, that looks a lot better. And why don't we zoom in on that a little bit more? All right. Now, I wish it didn't do that, but as you can see, this is definitely the normal line. It is definitely perpendicular at this particular point. So the answer should be negative 0.25 plus 4.25. Whoa. Huh? What's going on? All right. Whew. Now, they want this in ax plus by plus c. Okay. All right. So that means that I have this format right here. So why don't we bring everything over to the right? Okay, so I'm going to have 0.25x plus y minus 4.25 is equal to 0. And I'm pretty sure they want everything in terms of whole numbers. That's usually what they want for the general format. So if I multiply everything by 4, well, this will go away, and this should go away too. So I'm going to have x plus 4y, and this times 4 should be 17. Let me just make sure because I don't want to do this more than once. So times 4. Yeah, okay. So my final answer should be x plus 4y minus 17. This is the thing I actually type in. X plus 4y minus 17 is equal to 0. Super duper. All right, how about this one then? Y is equal to 4 divided by x at x is equal to 1. Okay. 4 divided by x. So that means f of x is equal to 4 over x. Now, this could also just be rewritten, in a derivative-friendly format. This could just be 4x to the minus 1 power. When you take the derivative, this minus sign comes down, and then this minus 1 has a minus 2 on top, which makes it negative 4 over x squared. There you go. And we need to know what the slope of the tangent line is at x is equal to 1. What is going on here? Can I escape out of that? I don't know why there's a black screen there. Anyway, all I need to do is plug in a 1 right here, and that'll tell me the slope of the tangent line at this particular point. It should be negative 4. Okay, but the slope of the normal is negative 1 over m. So this slope is actually positive 1 over 4. All right, let's plug it into our point gradient form. So I'll have 1 over 4, and this will equal y minus some point divided by x minus some point for some x1, y1. and we need to pick a point. Why don't we pick x is equal to 1? That point seems pretty good. So if I plug in a 1 for that one, I just need to know what f is when I evaluate it at 1. Well, remember, f of x is equal to 4 over x. If I plug in a positive 1 there, I should get a 4. Yep, pretty good. So why don't we type in a 1? And we're good. So let's start doing our good algebra here. So this is just going to be 1 over 4 times x minus 1 is equal to y minus 1. Okay, let's distribute this. So I'll have a 0.25x minus 0.25. And it wants everything over on the left-hand side, so why don't I just go ahead and add 1 and subtract y. So I just added 1 to this side, I subtracted y from both sides, and now I have 0 on the right. Okay, almost done. So let's combine like terms and get everything looking nice and neat. So this will be 0.25 minus y, and this will be plus 0.75 is equal to 0. And it looks like all I got to do is multiply by 4 again. So if I do that, I should get x minus 4y plus 3 is equal to 0. So x minus 4y plus 3. Okay, let's see what I got. Plus 15. What did I do wrong? This is supposed to be plus 15. Okay, what did I do? Oh, I was supposed to put in a 4. Oh, duh. Haha, I'm an idiot. So we plug in a 4. Now we're going to add 4 to both sides. And this will actually be 3.75. Yeah. Times 4. That would be 15. Ugh, I'm an idiot. All right, so don't make a boneheaded move like that. But yeah, you add 15 to both sides. All right, my bad. So I plugged in the same 1 value here. It should have been the y value here. When you do that, then you're good. Okay, so that's how you do this particular piece of homework. Okay, so now we're back in here. Why don't we try question 2? Hopefully we get a little bit further. Okay, so this one seems like we got a little bit of doing to do here. We got x squared minus x minus 2. All right, so here we have to factor it into 2 different things. It looks like we're definitely going to have x somewhere over here and x somewhere over here, and it's going to be plus something and plus something. All right, so now I need to figure out what 2 numbers here. Well, what 2 numbers multiply together to get negative 2, but add together to get negative 1, right? Well, it looks like minus 2 and plus 1 would work for that, because negative 2 times 1 is negative 2, and negative 2 plus 1 gives you minus 1. So I'll just have minus 2 and plus 1. Pretty good. Now, next question. Where does the curve this cross the positive x-axis? Okay, so all I need to do now is just set this equal to 0 and solve. Well, I already factored it here. So if I set this equal to 0, either x minus 2 equals 0 or x plus 1 equals 0. Well, if x plus 1 is equal to 0, that means that x has to equal negative 1. But we're not talking about that here. This is on the right-hand side. This is where x is positive. So if we look over here, x minus 2 is equal to 0 whenever x is equal to 2. So my answer here is just going to be 2 and 0, because the y-intercept, it crosses the x-axis whenever y is equal to 0. Okay? Now, it says find dy dx. Okay, so if I just come back up to here, I bring the 2 down, and that'll be 2x, and then this just turns into minus 1. So 2x minus 1. Nice. Find the value of the gradient where the curve crosses the positive y-axis. Well, I already know where it crosses the positive y-axis. It's 2, 0. So all I need to do is just plug a 2 into here. 2 times 2 is 4. 4 minus 1 is 3. All right. Work out the equation of the normal at this point. Okay. That doesn't seem very hard. Yeah. Let's get back to Mathematica here. So if the slope is of the tangent line is 3, then the slope of the normal line is negative 1 over 3. Okay? So I'm just going to use point gradient form again here. Let me just get that out of the way. I have negative 1 over 3, and that'll equal y minus some point divided by x minus some point for some x1, y1. Well, we just need to pick any point on the line. Why don't we use that x-intercept here? 2, 0. That seems good. Yeah. Okay, so I'll just type in a 2 here, and this is just a 0, so we might as well just get rid of it. And what format do they want it in? They want this in general form. ax plus by plus c is equal to 0. All right, that seems fair. So why don't we go ahead and cross multiply? So I'll have negative 1 over 3 times x minus 2 is equal to y. I might as well subtract the y from both sides and distribute this negative 1/3. So I'll have negative 1 over 3 times x minus negative 1 over 3 times 2. And this is just minus y is equal to 0. Now, if I multiply everything by 3, it looks like I'll just have negative 1x. Yeah, so negative x plus, wait, I have to have the y next, so it's just going to be minus 3y because I'm multiplying each thing by 3, so minus 3y. And then this just becomes a plus 2 is equal to 0. Yeah, that seems good. So why don't I actually, these negatives are bothering me. Why don't I say x plus 3y minus 2? Hopefully that doesn't throw it off because there's too many negatives here. I just multiplied everything by negative 1. I'm sure if you input this, it'll take it. But let's make it stylistically a little bit nicer. So x plus 3y minus 2. Exactly the same thing. All right, x plus 3y minus 2. Yay! Oh, what did I get wrong? Oh, it's from this one up here. Okay, I got every part of this one right. Nice. So looking at it, clearly I made a boneheaded move on that one thing. I inputted the x when I should have inputted the y. So I could just go back in and, do it again. But, you get the idea. It's not that bad. All right, I made this specifically for student X. You know who you are. But, I figured that a lot of people might find this video very helpful who are also in this class, but maybe they haven't gotten to the homework yet. So I hope that you found this video helpful. Obviously, try not to make a boneheaded move like I did. I would have to go back in and redo it in order to get the answer that I wanted. So just be careful about how you input your X's and your Y's so you don't have to do it over again. But as you can see, if you know what you're doing, you don't have to take as long as I did. I was trying to go slow for educational purposes. Really, if you're flying at full speed, this shouldn't take you more than 10-ish minutes. If you were taking your sweet time, it might take you 15 or 20 minutes if you pause and take a break or whatever. And if you redo it like I would probably want to do for that one little question, it might take me 25 minutes because I'd have to do it 2 times. Or you could just be happy with your grade. I'm never happy with my grade. I would like to have perfection, but it's totally up to you. Anyway, good luck on your homework. If you have any further questions, anybody, please let me know. Take care. Bye bye.